I mentioned earlier that some losses do occur on the closed cycle system, and therefore a certain amount of makeup water is required to compensate for the loss. The makeup water is of high quality, produced in the demineralizers or evaporators and stored in the condensate tank. For makeup purposes, the water is usually fed into the condenser. During operation, the vacuum in the condenser's steam space causes water to flow from the condensate tank due to the difference in head. But how does the system know when and how much makeup to add? In fact, how is the level of condensate controlled in the condenser hot well? Also, how is the level of condensate controlled in the de-aerator? This simplified diagram shows how these objectives are achieved. Makeup water from the condensate tank is drawn directly into the condenser through this modulating control valve, which in turn is adjusted according to the level transmitter which is located at the hot well. In a similar manner, the flow of water into the de-aerator is determined by this particular control valve, which is controlled by signals from the level transmitter at the de-aerator. Let's see how this simple arrangement works during a plant shutdown. As we begin to reduce load on the turbine generator and boiler, we find that the level in the de-aerator begins to fall. The reason for this is that as the production of steam is reduced, a certain amount of shrinkage takes place in the boiler. Consequently, the boiler water level control system draws more water from the de-aerator. This in turn causes the de-aerator control valve to open up and so draw more water from the hot well. As the level in the hot well falls, more water is drawn from the condensate tank. When load is increased, the opposite situation takes place as the boiler water level increases due to swell. In this case, the boiler feedwater control valve reduces flow, the de-aerator level tends to rise, so decreasing the de-aerator control valve opening. This causes the hot well level to rise, thus causing the makeup valve to close completely. If the hot well level continues to rise, we must find some means of dumping this excess condensate back to the condensate tank. This is achieved by fitting a connection from the condensate system through a control valve back to the condensate tank. This is known as the overflow control valve, and its opening is determined by high water level in the condenser hot well. The level control system we are studying here is one typical example, but you must make sure to study your own condensate and feedwater system. Now, we still have a lot more to say about the condensate and feedwater system, but first, let's take a break to review in our